Here we have with us today Mr. Wade Bray, who is the Vice President of Head Acoustics Incorporated. And we have Mr. Dube, who is the Associate. And we also have Mr. Gratke, who is the Telecom Consultant for Head Acoustics Incorporated. So I think they're going to just give us a quick introduction and get started.
Okay, thank you very much, Sano. It's a pleasure to have your invitation and to be back here. As you may recall, I was here before talking about sound quality. So a great delight. And Pierre is our business development for NVH Consulting, our NVH consultant, and Jesse is the telecom consultant. So we have first of all, we are all enthusiastic about the same thing you are, and have been doing it from about the same time in our lives as you. And we have a span of technology here from about 1971 to the present day. All of us have built various things, and some of them are on display, plus some other goodies. So I'd like to start with some things from my own life, and I hope a relatively short PowerPoint, and then show you some other things. And we're going to open one thing up. So I'm going to talk about the Nagra IV-S stereo tape recorder, which was brought on the market through the world, but built in Switzerland in 1971. The Westrex 3D2 stereo disc cutting system, and I was for a while chief audio engineer of film production and recording studio that had a Scully automated lathe with the Westrex 3D2, automatic variable pitch and depth, and we had some peculiarities that we managed to figure out and solve along the way. So I'd like to talk a little about that. It's a very interesting technology that has evolved to the present day. And I was also a senior consultant at Jaffe Acoustics in Norwalk, Connecticut, and was involved in not only conventional acoustic design of music venues and so on, but also electroacoustic. And a patent came about that I was asked to get made for the company about a method of doing amplitude and phase modulation of multiple signal delays to release reverberation into a space from a specialized reverberator. So anyway, here goes. The Nagra Kudelski company was founded by a Polish gentleman who at the age of 10 in 1939 with his family escaped Poland right ahead of the Nazis. They went to Switzerland. He discovered as a very young man that he had a tremendous acumen. He designed and built his own very miniature portable tape recorder and recorded the Carillon inside Notre Dame Cathedral in Paris in one of the towers, and won a world prize because no one could believe that the quality of the recording came from a machine about this big that he had designed and built entirely himself. So with that idea in mind, he proceeded, and the company still exists. They built tape recorders from 1951 to 96 and are now very much active in high-end audio. A couple of things here from their history. In 1958, they brought out the machine called the Nagra III. Nagra, by the way, in Polish means it records. And very simple. And the quality, he immediately hired only watchmakers with the Swiss watchmaking apprenticeship background. And he said, we are making a product that can be utilized in the film industry, synchronized sound, the sync signal from a camera, getting recorded on a track that's split in phase in between a full track mono recording, so it gets canceled on the playback of the audio track. And the Nagra III became immediately, in hundreds and hundreds of units, the world standard for film sound. And the studio that I worked in had one of those. So that was 1958. Then they started doing all kinds of unusual things with this brilliance that Mr. Kudelski had. This is a machine approximately this big, which was installed inside the cylinder of a test torpedo in order to take data while the torpedo was running. And then they collected the torpedo, obviously without munitions, and were able to download the data. That was 1967. This one was 1970, which used 1/8 inch tape like a cassette, and you can see here the size in comparison with a hand grip and other things. This was designed to have the sync signal either from a crystal oscillator or from other connection by radio, and be fit in the pocket of an actor who would walk around and do whatever was needed. Then they would collect the tape and make the sync sound fit with the film. That's the model SN. So here's Mr. Kudelski, 1929 to 2013, holding the SN, his Model 2, which went up to Everest with the Swiss Everest team in 1952. The Nagra IV-S came out in 1971 and was made until approximately 1986, I believe, was the last year of production. And this one was in 1972, and it was used, I've forgotten which film, but it was either American Graffiti or Butch Cassidy and the Sundance Kid. And I found it by having some people in Hollywood that I knew on the lookout, and they said, we've got the machine, get it now before anybody else does. So I've done a lot of stuff with this, LP records, and bluegrass in the middle of the night at the Blossom Bluegrass Festival and so on in Indiana. So there's a nice picture of the 4S, and you're welcome to come see it. And we'll roll tape. That is brand new 1969 tape. We took the shrink wrap off it yesterday, and it's safe. It doesn't have the black backing, so it doesn't have sticky shed syndrome. This is what the Nagra looks like inside. And Mr. Kudelski said, we are a small company. We cannot afford to have service everywhere in the world. Therefore, the equipment has to be reliable. And the Nagra equipment is absolutely known for reliability, and there is a true story of this type of machine falling accidentally from a helicopter 150 feet above a sandy beach and being found running on the beach afterwards. I've had no trouble with it at all, and it still works, and it does an amazing job. It also has a pre-distortion circuit. When you align it properly, it knows what tape saturation is going to do, and it cancels it. And you run right up to the absolute saturation where you get total distortion, and it's completely clean, so you can't get grunge effects out of it. It's either clean or it's not, rather like digital. Here's Mr. Kudelski with a video machine he designed circa 1984. And now we go to the Westrex 3D2 cutter head. A company called Sword Out Productions and Universal Audio in Scottsdale, Arizona, had this machine, and not the very one in the pictures, but very similar with the Scully lathe, and I was the perpetrator who cut disc masters. Here is the Scully lathe, which is a welded steel framework, approximately 3/4 of an inch thick. It has a big box inside that's held by steel webs. The box is full of 300 pounds of sand. The drive motor is in that, and there is an intermediate pulley, and then it comes back, and the motor is directly under the disc, but there's an intermediate pulley, then it comes back and drives the disc. There's a lever transmission, shifts it to 45 or 33. It just is absolutely silent. It has a worm drive system that's driven by a constant velocity transmission with a knob that's just out of the picture here to the right, where you can change the pitch, or it can be changed by an automatic mechanism, about which more later. And the cutter head is on a cantilever suspension that drops it down at the correct angle, and just enough force for it to ride on an advance ball, which is a ruby hemisphere, directly behind the stylus in the direction that the disc is coming to the stylus. That is how it's done. Here is the Westrex cutter upside down. This was designed in 1957 and was the first stereo cutter at the advent of stereo LP records. The idea of 45-45 stereo involves two orthogonal 90-degree drives, one this way, and hopefully, if it's all done right, there is almost no crosstalk to the opposite channel. This whole works, sits like this, and produces cutter motion that is a complex shape. But also, for the variable pitch and depth, Scully Westrex system, which they co-developed, utilizes a DC bias voltage that is on the drive coils, and when the preview head on the playback machine recognizes either phase difference at low frequencies and or amplitude difference, it puts positive DC on, pushes the stylus straight down, and makes the groove wider so there's room for this without getting lifts. The design is a torque tube. You can see the cylinder here. The cylinder goes back to the back. Here are the drive rods. The drive coils and feedback coils are here with biconic drive rods that can displace a little bit. The stylus goes in here. Here is the heating coil cemented on, and the heating wires you clip onto little electrodes from the power supply, and you run the heat up in order to have a clean groove. There are flat springs. You can barely see them at the back, which are also orthogonal and in the same line with the drive coils. So then there is a tie rod, a torsion spring, which goes back and goes into a block at the back. The vacuum pickup and the advance ball are removed in this picture. Here the vacuum pickup is in place, and the advance ball is in place, which is this mechanism. And if we go back a couple of slides, this knob adjusts the advance ball height in order to get the groove, and you look with a microscope when you're doing it. So the microscope is on the left side in that picture. If we look here, here is an updated one where they have tapered the torque tube and reduced the mass, and you can see where the advance ball is right here, the ruby hemisphere right behind the stylus, and there are the heater wires for the stylus, and you have a vacuum pickup. The stylus heat and the vacuum amount are very critical. If you have not enough stylus heat, the groove is gray and you get a hissy recording. If you have too much, it gets score lines on it, and there is a rather narrow zone, which is just right where you get a beautiful, beautiful surface. You have to know what that is and keep it there. The vacuum pickup has to be not too much, because if it's too much on your recording, you actually modulate the cutter. And if it's not enough, you can drop the chip and maybe have a fire because of the stylus heat. So that's critical. We used a milking pump with a tank about this big around and that tall to smooth out the vacuum so it wasn't impulsive. And that was in another room, so we could be quiet and hear what was being done through speakers. So here is the most recent version of the modification of this antique but still viable cutter head, utilizing a very low mass, narrow torque tube. There's the stylus, and here you can see better the drive at one end of the torque tube, the flat springs at the other end, and the tie down. So the whole thing works. if you look at vertical tracking angle and what it is, I also want to mention a stylus called the cap scoop. The cutting system has this is on the right-hand side, basically the cylinder that I showed you is the horizontal piece, and the cutting stylus is vertical. So the tracking angle is the point of contact up to the fulcrum point, which is between the flat springs. That distance, this angle is, the idea is to keep the tracking angle exactly the same on your playback device. However, the fulcrum point to contact on the stylus is much, much shorter than it is on the disc cutter. Therefore, the section of a sphere which is swept out by the playing device is a shorter radius than the section of a sphere swept out by the cutter. The CAPS company, C-A-P-P-S, made styli for various cutters, principally Westrex, and they made one called the cap scoop. And the cap scoop had a section of a sphere leaving the surface, the flat surface perpendicular to the motion of the disc coming. The idea was not to compensate exactly this radius, but to compensate split the difference between the radius of the plain typical cartridge and the radius of the cutter. And the result was that if you did it right, you got a very, very, very good groove. The other nice thing about the cap scoop was the surface quality of the finish was better than any other styli. They quit making them, but our company had gotten a stash of them, and that's what we used. So the amplifiers in ours was the last part of the first generation with vacuum tube electronics. The amplifier was called RA1574D, had 7027, not A, but 727 vacuum tubes, 450 volts max plate, and Westrex ran them at 600 volts, so they didn't last very long. And you had to watch them because they would start to gas out and do nasty things, but while they lasted, you got wonderful results if you were careful. The RIAA, and I want to drop out of this for just a second and get that. The RIAA curve for playback is exactly the opposite in the disc cutting. And the idea is to have a constant amplitude cut at all frequencies. And the red curve is a constant amplitude cut. The blue curve is the approximation by having 3 different time constants so that you don't have to have 60 dB of gate difference between 20 hertz and 20 kilohertz, only 40. But setting this up was extremely critical, and there's a Rube Goldberg board that has all kinds of weird parts, resistors, capacitors stuck on it that had to be done for each channel of each cutter head individually. And then you had to tune the thing extremely carefully for 26 dB of feedback, and if you didn't do it right, you would burn out the cutter. I never burned out the cutter, thank goodness. And when it was right, and this supposedly antique monster of mechanical system would make beautiful stereo hi-fi records. And yes, the Westrex works even in this original version. So that's the idea, which I now can drop that, about the RIAA, etc. So let's go back in here real quick. Variable pitch and depth. There was a preview head, which I mentioned before, where the program would go by that before it would get to the playhead driving the cutter. The preview head would tell the automation system to change the position of the knob. And you see the knob moving back and forth all by itself like this in order to closely pack, spread the grooves, etc. So you've got the maximum spacing without any intersections of the grooves or touching of the grooves. On the other side of the automation was on the Westrex side with the amplifiers. There was a network so that they could apply DC, matrixed into or multiplexed in, if you will, with the AC drive, so that the stylus would be able to move from neutral going to ODC downward to make fatter grooves when necessary. And the whole thing worked really very well. We had a problem that for reasons we couldn't tell, one of the amplifiers would sometimes flutter. It was one or the other. We couldn't ever tell which. When that would happen, there would be a very low frequency transient, and the stylus would do this enough that you would, if you look through the microscope, you would see spaces with nothing. And then you'd come back down, and that killed the master. Acetates are expensive. Of course, you can't send that to the pressing plant because it's dead on arrival. So we had to do something about it because we were getting that maybe once every 5 records. I had a try at also helping the tubes a little bit by reducing the plate voltage about 30 volts by regulating, and that stopped the problem completely. We never had any more spurious lifts anymore. So that's how we did it with technology of approximately 1968, going into the 70s and early 80s. So now the last one is I got to work at Jaffe Acoustics in Norwalk, Connecticut. As a senior consultant, got involved in the electroacoustic work. He was a visionary, not only a wonderful acoustician for real physical acoustic concert spaces, like the Bass Performance Hall in Fort Worth, Texas, but also he had a vision that an inexpensive modular electronic system could be used such that high school auditoria, theaters that had fallen out of use as movie palaces, etc., could be repurposed with help from electroacoustics in such a way that no one would hear at all or sense that there was anything electronic, quote unquote, or amplified going on, and simply be able to have the correct early reflections at the correct times in the correct locations by means of electronics, and to be able to switch the system from a mode for popular music to a mode for classical music with lots of reverb, etc. So it went very well. He never got to do the global modular thing as he'd hoped, but many, many other good things. So here's a little bit of background on electronic architecture, and there are two aspects of it. One of them is what to do with artificial reflections when you can't have real ones. And here is a 4-stage canopy, which is an extension of a real physical reflector out over the audience in order to help the low energy strings, the violins, to be able to get reflected sound at the correct timing into the audience so that the sound of the orchestra was clear and all in tonal balance. Jaffe's were the acousticians for the renovation of the Oakland Paramount Theater in California, the movie palace, for the Oakland Symphony. They could not have the reflector, so he put a pair of flush-mounted electric condenser microphones in the forward part of the reflector that did exist, and then ran it through amplification and a line array loudspeaker system to get an electronic 4-stage canopy, and it worked very well and still does at that hall. Also, there were low-frequency loudspeakers in a ventilated ceiling, which you saw, but which was coupled into a larger volume, and that kind of rolled around and came back at the right time, around 150 to 300 milliseconds, back into the hall for orchestral warmth. Then, one of the big things that was a big change for the company was that NBC television in 1980 approached Jaffe and said, we want to have the New York Philharmonic in Studio 8H, which, by the way, is the Saturday Night Live studio, and still very much exists. It's the biggest of the broadcast studios in the complex, but it wasn't really big enough for a symphony. So he said, they said to Chris, what can you do, Chris Jaffe? He had some ideas and had already tried, just experimentally, kind of secretly, using studio reverberators, which had gotten to a pretty good development by that point, but they didn't work because the early reflections in the room would start to densify. Then the reverberance would come in, and the studio reverberator was already too dense. There would be a discontinuity, and it didn't sound like the room, and it wouldn't ever sound like the room. So he said, we need a non-recursive reverberator that has wide tap spacing, so that in between the repeats of the reverberator are actual room reflections that are being fed into this device, and that builds up the reverberant field. That was called the NBC delay, and they still called it that. It was manufactured by Knowles Industrial Research in Chicago, and was designed electronically by a gentleman named Malin Burkhardt, who's now 94 years old and is the chairman of our company, Head Acoustics, Inc. This is the NBC delay. This was a 72 tap unit, and there are still some Leontine Price Zubin Mehta performances on the internet from this series of live broadcasts. Here is the other side of the Jaffe technology, which is boardroom speech lift and conference room speech lift, where this was the GE World Headquarters. I got to design the second, this was the picture of the first stage, I got to design a redo of this room. And there's a line array of microphones, which are flanked by loudspeakers, pushing on one side and pulling on the other, so there is a null, which is about 20 dB deep at the middle, along the center line. And then there is a matrix, so this mic does not feed its own speakers. With the appropriate delay, it feeds these at a low level, more delay, these more, and so all microphones are cross-feeding with the delays and the level control accordingly. And the result is you walk in this room and you say, wow, this is just a really nice room. I can talk and I can hear. There's no sense of anything artificial. Everybody sits down, and then you turn off the system, and they feel like they've been hit by a ton of bricks. And what in the world happened? It's like dead. And then you put the system back on, and it's natural and easy to talk and hear. There's no sense of anything unusual about it. The other side was, this is not exactly right, 2x2 ceiling tiles like this, with a loudspeaker and a microphone. You had to install them with a template so they were exactly spaced. And there were two modules consisted of two panels of a module. Speaker, in phase, microphone out, microphone in, and that was the summation. And again, it was matrixed all around. We did one, Jeff did a bunch of conference rooms that way. Very, very, very effective. So here is the idea of the electronic reflected energy in a music space. This was a development one in the church in Fairfield, Connecticut. And we had, for example, two microphones with preamps, level controls, then equalization for which was above basically 300 hertz, with delays so that they came at the right time and they were typically positioned at the right place for the direction of ideal road reflections in the 60 degrees to the side, 40 degrees to the side area. Then there was late arriving low frequency information with low pass filtering and delay that produced the low frequency warmth effect. And in theaters, they would put those underneath the floor, and the sound would come up through those mushroom-shaped grills underneath the seat, which worked very well. And the rest of it was the reverberation part, and that was, as you can imagine, the hardest part, partly because we couldn't afford very many reverberators. We could afford 2 of these NBC delays. Our ODS was something developed in England by a friend of Jaffe Acoustics, stood for a reverberation on demand system, which was basically a gate that when the system is, the reverberant field is lower than the direct sound of the mics, it lets the sound in but not out, and when it's the other way around, it lets it out but not in. It's not exactly a gate, it's separately adjustable level controls, and if you did it right, you could get several more dB before feedback, very effective use, a Rod's device for each reverberator. Then came my part, which was to have individual time delays for each reverberation release loudspeaker with different delays and with different modulating functions, which were a triangle way of modulating the phase, carefully set sine wave modulating the amplitude at slightly different rates, very slow, and at slightly different amplitudes. And then the whole thing was, the loudspeakers disappeared. You could not localize them because of the shifting phase and amplitude. The gain before feedback rose markedly. And you could also, by being very careful, get the animation in the reverberant field such that you had the sense that musical sound was decaying and moving away around you, and not just dead decay. So that was it. And they called my thing the dither. Just a little background, the Jaffe Acoustics company had a parent company that Chris Jaffe founded, which was called Acoustic Angels, and did pro bono consulting. And for whatever reason, I never knew, and I still don't, my patent got assigned to Acoustic Angels. So it's called Method and Apparatus for Increasing Perceived Reverberant Field Diffusion. I'm not going to go through reading it. If you want to see it later, you're certainly welcome. But this kind of leads into something else. This was part of the presentation in a memorial session of the Acoustical Society of America about the life of Chris Jaffe, who was very renowned and very controversial, but very renowned and loved and very effective in the world. So this is the facade of the Bass Performance Hall in Fort Worth, Texas. And so it's good, I said, that Chris Jaffe had pre-assured the existence of Acoustic Angels, because that's doubtless who he's with right now. And these are the only ones that allow themselves to be seen, the ones in the Bass Performance Hall. So in acoustics, he had a unique ability, both technically and in personal ability and style and peopleness, if you will, such that he could explain technical things and complex things to anyone, and he would enfold them in the energy of his spirit. He really literally orchestrated through the science of acoustics and its practice a transfer function involving the human mind and physical space and musicians and everything else. And so he is greatly missed, and that was my conclusion to that. There's a lot more of that, but we don't have time. So that's essentially my part as far as the presentation. And some props here. This is, first of all, in time sequence. I was the audio engineer for a restaurant chain in Phoenix and Mesa, Arizona called Organ Stop Pizza that had big Wurlitzer pipe organs. And the man who founded that actually built the house that my parents and I bought when I was a freshman at Arizona State University. And his first Wurlitzer pipe organ was in there. So he dragooned me to do recording and audio engineering and design the PA systems for the restaurants. From scratch, I designed and built this vacuum tube, 4 input, 2 output. You can assign which channel an input goes to by telephone switches. It's all done on vector turret sockets and terminals inside. DC heater supply, 5751 vacuum tubes, and it still works, and you can see the glowing filaments if you choose to look. So that was 1972, and it made a lot of LP records for Organ Stop. Then in 1973, a friend of mine who had a little recording studio in Phoenix and a small lake decided to try building his own condenser mics. So we made a 3-person project. I did the electronics, he did the mics, and my father, who was a precision optical manufacturer for the aerospace and military, lapped the stainless steel anodes. So these use the 7586 triode New Vistor and run at about 200 volts on the plate of the tube and about 180 by space charge. The grid is directly connected to the anode. With a AC grounded plate, it's a cathode follower, so it corrects the phase reversal that is inherent in any condenser microphone. When you have a push and you have a smaller space, you have higher capacitance and hence lower voltage, so you get opposite electrical polarity to the acoustic pressure. So that's corrected by the cathode follower. In here is a regulated DC supply. The pilot light is on that, and for the high voltage and also for the heater. And it's very pretty inside, and afterwards I want to open it up. This still works too. We were playing with it and listening to it yesterday. Homemade condenser mics. And then the Nagra IV-S. I was doing recording for other pipe organ equipped facilities and decided not to haul around a monster reel-to-reel machine anymore, so I was looking for a Nagra. found this one and have been extremely happy with it. It still works. I'm eventually going to sell it, but the value is still rising right now. They're being rediscovered. This one is very rare for two reasons. It has the expanded cover for large reels. Most of them have only the cover-to-cover 5-inch. And it has the even rarer complete service manual with all schematic diagrams. So these are just beautiful machines. In order to make it play, for example, you would do that, which also engages the roller. And there's a stroboscope here. The guides are ruby. The tape guides. There's the capstan, which is crystal controlled and has a phonic wheel with about 600 teeth on it and a magnetic pickup that locks into the quartz oscillator. And inputs and outputs on both sides. You can put a crystal into it. I have a little crystal with me for crystal sync radio bloop filmmaking. And so there's no sync cable involved and so on. And one of my favorite recordings with this was with a friend. We had my Schiit microphones. My friend held the mics like this. We had cables between us, so we had to go on the same side of trees. I had the recorder with the 12 D-cell batteries in it. It doesn't have those right now. So it's heavy, but not as heavy as it was then. My shoulder finally grew back. And we walked through the Bean Blossom Bluegrass Festival in 1982, in June, in Monroe County, Indiana, Brown County, I'm sorry, Indiana, the Bill Monroe Ranch, and there were wonderful bands just spontaneously making music around campfires all through the campground. So we wandered around and recorded them. And just recently, I was able to transfer the recording, and I was quite stunned, really, how good it is. And,
I actually have
these
those
machines
recordings
really work.
on my laptop, so as we get to the end, if you guys want to hear some of it, we can definitely punch it through my
Okay,
headphones.
so I'm off the stage now. Who's next?
You're gonna leave it run?
Pardon?
You're gonna leave it run?
Yeah, I'm going to leave it run. I may as well shut it off so it'll discharge. It'll go down to 90 volts where the lamp stops, but it'll still have charge at 90 volts when we put it up. So I'll unplug it and wait a bit and take it apart while other people speak. So please, we have half an hour left, and
I bet it's
welcome.
Work your way this way.
Okay. All right then, one little short additional thing. I had mentioned, and I think Sunho was encouraging me, I was worried about time, that when I was at Kimball International in Jasper, Indiana, which was 1976 to late 1983, I was designing loudspeakers and also doing some voicing for electronic organs right before the death of the electronic organ. And one of the things that we did was a tone cabinet for the high-end Kimball J900 Xanadu, a 3-manual home organ. A very, very nice instrument, a very good instrument even now. And the earlier tone cabinets had the revolving Leslie loudspeaker. And so we decided that we might be able to do that with no moving parts. And so using bucket brigade delays and modulators, we had a cycloid and a sinusoid, which were offset in phase in just the right amount. The loudspeakers were on 90-degree faces, and then the electronics in the rest of the cabinet, 120 watt amplifiers, and there was a bass driver and a separate enclosure inside. The whole thing was about this big and about that tall. And it also had ramp up and ramp down, so that the quote-unquote revolving speaker would come up to speed like this, and when you shut it off, it would coast down, and it had the so-called chorus mode where it was, doing this like the Leslie. It sounded better than the Leslie at the same size. It sounded very, very good. And there are a couple of LP records of the Kimball Xanadu Christmas and the J900 Xanadu that were recorded with that loudspeaker, with acoustic, with microphones on that. And they can develop these records. Okay, enough. So I'll get busy here. If you hear a bang and hear me yell or jump, please come to my head.
Well, my toys aren't nearly as cool as Wade's, but I did bring a few things. This is my headphone amp and DAC from Schiit Audio up in California. This is the Mjolnir 2, and the DAC is the Gunjir Multibit. And the two tubes here are, they are Philips Mini Watts from 1969 that I bought new old stock. They sound great. The headphones here are Odyssey LCD X with the fancy little carbon fiber headphone or headband, but it sits nice on your head, no pain whatsoever. And then I built a quite poorly, I might add a balanced cable for them.
You are too modest.
Well, from far away it might look okay, but the heat shrink work could use some help. I run it through USB. I do have, and it's balanced, output out of the DAC, balanced into the amp. It's on, it's getting warm, so again, as time progresses, we could have a quick listen if you want to the bluegrass stuff. Familiar with Schiit audio, their stuff is all gray, it's all silver, which is cool, but I like black, so I had these anodized, and I think they turned out pretty sweet. So, and the black complements the yellow came with. The other guy over there is my Dynaco ST-70, not original anymore, but I got that from my wife's uncle who came to Michigan State many, many, many years ago, and they would have just these wild parties in their dorms, and I think they were one of like U-shaped ones. So they would set their big voice of the theater speakers, kind of one on each side, and they would just blare music. And because of the shape of the building, they would just send music out.
And the efficiency of those speakers.
He became very good friends with the football coach at the time, who would frequent these parties and say, "Turn that down, we're trying to have practice." It wasn't working. But I've gotten from him 2 sets of speakers and that amp, and I'm going to pull up some pictures here of my handiwork. So the ST-70 is actually on, so it's nice and warm, but the picture looks much better on my laptop. But in short, there's a nice blue glow that's from the tubes. This is what we looked like before. It was chrome on the bottom, and the cover, which is sitting behind Jesse, was brown, kind of like the brown of Judge's shoes, which is fine for shoes, but for amplifiers is less desirable, I think. This is when we took the cover off.
Oh.
Sorry.
And in a chicken coop, you said?
Yes, yeah. So the base is supposed to be chrome. It is covered with maybe 1/8 of an inch of dust. Transformers were shot. The tubes I was able to pull off of the sockets. I was able to clean it off a little bit. A little bit better look at that. Anyway, that was the boring stuff. Now the cool stuff was the building part. I turned my garage, much to my wife's chagrin, into a paint studio. There's a guy that sells kits for these, and he sells the chassis too, but I wanted to at least keep a little bit of this in its original state. So I stripped the chassis, I stripped the cover, I did a little bit of painting, some matte black and some semi-gloss black paint. There's my garage and my paint hoods. One of the options for the kit was these Russian paper and oil caps, which I really don't know what they do to the sound quality, but it sounded cool, so I figured I'd buy them. It came with a little bit of heat shrink because there's no heat shrink on the leads like you can see there. Those actually mounted to the bottom of the board, so my little building station at home has been upgraded since these pictures, but building of the board. All of this comes with fabulous instructions. If you can read and you can, see 2 here and see 2 on the board, if you can put stuff in, you're golden. So I thought. There was actually one of the resistors that went on the bottom side of the board, and I mounted it on the top side. So when I put the board in, it hit up against the chassis. I of course had cut all the leads off, so they were super short. So I had a fun time trying to get that back into place. The wiring was not too terrible. Got the transformers on there. This thing weighs about 45 pounds. Now that I'm done with it, and it's all in the iron in the transformers. So a lot of little stuff. I really honed my soldering skills. That's all wired in. So it was several hours of painstaking work, but I did have an issue with it. I would turn it on and I would just start blowing fuses, and I was blowing rectifier tubes left and right. The rectifier tube, I put in some new ones that I bought, and it worked fine. And the reason I had problems with the fuses is because I had a grounding issue. So I took it to a guy, we did a bunch of measurements, and he reassured me that my wiring was fine. But the binding posts that are on there aren't the ones that came with the kit. And I wanted to be able to tap a few different impedances, so I can put in 4 8-ohm speakers in there. Well, on my way home, after having spent a fair amount of money on this guy to figure out that I had a grounding issue, I encountered a man with a little bit of road rage to where he pulled out in front of me and slammed on his brakes. Well, 45 miles an hour and 45 pounds not buckled in has terrible consequences. So the chassis bent a little bit. If you look at the transformers, they're a little bit off kilter, but it works. Sounds great. And here's a couple of shots that I took with my camera. So this was done with my DSLR, 10 or 15 second exposure time. Nothing is doctored here. The blue from the tubes is what it is, and that's how we see them. Zoom shot. They look a little bit nicer on my laptop screen versus up here, but you get that nice orange. And when I listen to them, I usually listen to them with the lights off, so I can just stare at the tubes.
Yeah, well, really, you guys are probably wondering what a telecom consultant does. Telecom basically is making phone calls, right? Using cell phones, desktop phones, and now even lately making calls from Bluetooth loudspeakers paired to your phone, so you can do hands-free, conference room calling, things like that. Even in a car now, you can pair your phone to the car, and you can drive around and make phone calls. You can use, speech recognition like Siri. You can do navigation, all kinds of cool stuff in a car. Well, one of the reasons why we're called Head Acoustics, because we made these. So it's a head that listens and talks. So we call this the Telecom Head. So I can test any kind of device like headphones, cell phones, Bluetooth devices, which I have here. I have a Bluetooth device. So we actually make all the test equipment that essentially tests all these devices. So, it's all fun to get to play with all the audio stuff at the office on our spare time, but, during the day we actually do have to do some work and get to play with these kind of toys. Now, one of the main things I do is do a lot of, I don't know if you guys are familiar with like Apple CarPlay or Android Auto. I do a lot of certification for that. So I kind of have like a demo of that it's just imagine this being in the car and this being the audio system in the car. I mean, I can actually make a conversation between these two guys. So I'm just going to run a test, and I'll explain what it's doing. So my volumes aren't too high. Theoretically, everything should work. It should start playing some speech
The
out.
last switch cannot be turned off.
So that's coming out of the loudspeaker.
Tell the
Okay.
depth well.
So these are phonetically balanced sentences, and they're designed to kind of cover the spectrum of a human voice, both male and female. What's going to happen is going to do a bunch of speech out of just this,
Like fast
and it's
music.
going to do a bunch of speech out of just this.
Makes
And then the second round through, it actually has them interfering with each other. So they call that double talk. Right? So when you're talking on a phone, you have two ways going. You want to try to barge in on somebody. A lot of times, the other end of the call is going to, have some degradation. So there's like attenuation. So you can see us talking on the hats. So pretty much any Bluetooth device, any device that pairs with a car, any conference room phone, cordless phone, that's pretty much telecom. So yeah, the speech gets interesting.
The shaky barn fell with a
If you listen
loud
to some of the
crash.
sentences, they get a little funny.
Like a bright rose without leaves.
A pencil with black lead writes best.
Yeah.
Blow deep in
Now the
it
funny
and
thing is
rise
these are all
to
standardized, so I get to listen to these all day, and you do start to have dreams about them. And you start making some up, so that's the best part about it. Is no one's gonna know you're making them up because they're all kind of gibberish anyway.
We frown when events take a bad turn.
But I think you get the point. I don't need to go entirely through the thing. So.
The hogs were fed chopped cooked.
And then there's also some new applications out there, like Wade had talked about some stuff he did in the conference room when making zones, right? So now imagine doing that in a car. So that's called in-car communication, or ICC. So we actually make a testing system that does that now too. So that's pretty cool. And I was developing that technology back when I was at General Motors about 5 or 6 years ago. And now it's starting to get into cars now. They're trying to enhance the experience for all the passengers in the car now, instead of just the driver. Now it's pretty much everything in the car is going to be a zone, have their own audio, their own media. They can communicate with each other, and the driver doesn't have to turn around to talk, anymore. So, and there's also some devices like if you are familiar with the Google Home or the Amazon Echo. These are things really cool. I mean, you can basically just talk to it and then browse the internet and get you some answers back, or order something for you that you didn't want or whatever. But I test those as well, so there's the speech recognition aspect of it, so I can actually play speech out of this. I can simulate any acoustic environment, whether it's in a conference room, it's in a pub, it's in a dorm, pretty much anywhere, and inside a car even. We also have the software that can do that. It's basically a speech utterance database, and we can really play any audio out of it. So I'm going to just show you quick demo of that. And I just got to make sure. Now I could use either Hey Siri or I could use OK Google. So what I'm going to do OK Google because it's a little bit works a little bit better, honestly. Plus I recorded the Hey Siri when I was a little bit sick, so my voice doesn't sound like it. You have to train your voice on your phone, so it doesn't quite work as well. I may not have enough bars for it to actually work, but we'll try it. Okay, Google.
What is the weather like outside?
Should show the, no, it is talking, it's just you can't hear it, but so it's showing the weather. So essentially you can have your own script of all this different speech, and you can go through and toggle through and say it passed or failed. The nice thing about it is that you have the response, so you know what it did. So you'll know if it's right or wrong. And it just lost my network connection, so that's always a problem. But it did work. It did recognize it the first time, so that was nice. So this is just some of the things that I do. There's also some cool things like virtual reality audio. So a lot of gaming systems now are trying to figure out how to make sound, virtual sound. That's some very, theoretical stuff that I think we're trying to get into testing. But it's very early in its development, unfortunately. But a lot of cool stuff. So I don't know if there's even any questions about like some of the stuff that we do or some of the stuff you guys might be interested in. I mean, we do this kind of stuff professionally, so and also for fun. So I guess we have that advantage of doing both. Yeah, go ahead.
So with the head unit,
Yeah.
are you testing the acoustical environments, or are you testing like you're testing the frequency response of speakers, let's just say?
Well, I guess the answer is yes.
Oh,
To all of it.
both?
So yeah, we can technically we have really cool I call them surround sound systems that essentially simulate any background noise. So we actually have we can record it with a head, or we can use a headset. I mean, either way, we can walk around. We can make these recordings. Kind of like how Wayne was talking about earlier, walking around with the microphones, record at Jazz Festival. We can do the same thing, but with headphones, or just walk around with this on a cart and do that. Then we can actually calibrate it to equally play back in the field of the head, and so we can simulate a phone call, a conference room conversation, things like that, like a Skype call or FaceTime. And then also, if you just want to test loudspeakers, now you could use the head, but really we probably just use a single microphone at a certain distance. And there's some standards for that, which I actually did measure those clips with that. So I was kind of doing two things. I was seeing what we could do with our software, and also seeing how well they worked. So it turned out they were awesome. And so maybe my next time, well, my buddy's building a house, so as soon as he has his bar ready, we're going to have him in there. So.
How many pictures?
I do not have any pictures of them with me.
They have a sealed bass cabinet. They have a mid-horn that they call a squawker. And then they have a...
We could probably pull up on the internet, though, actually. We could probably do
I don't
that.
have any
Virtual
signal.
solid, they're about that tall.
Yeah. And I think they each weigh, I think they're about, I don't know, 50 pounds maybe? 50 pounds.
Oh, at least, more than that.
And, but we could even get one of them in the car here, so they're,
They were about $3,000 or $4,000 each time,
yeah.
and you got them for what, $400?
Yeah, so the newest versions now go for about $4,000 a piece. So, and these are 1985, and they actually are probably just as good or better than the ones that are built now. So, some of the electronics are actually better from back in the day. So it's all analog, there's no digital circuits in there. So,
They survived the time really well, too. A lot of the surrounds of some of the low-frequency drivers, don't fail over a period of time. These things really have...
yeah, they stood the test of time for sure. Yeah, another cool thing, like just back in beginning of January, We went and did a show at the ALMA, which is the Association of Loudspeaker Manufacturers and Acoustics. So all the people that make the woofers were there, you know, but a lot of them usually just do speaker testing, right? Because they just want to make a woofer and they want to test it, or a tweeter or whatever. But now all these things are going into these things, right? So now these guys are being asked to do Bluetooth testing, and they're supposed to be doing all this system level testing, like making calls with this, or just streaming audio. Now it's just not a loudspeaker component anymore. Now it's the whole system you have to test. So that's the other thing that we can do. We can test all the components as well as the system. So there's a lot of other systems that just go out there and measure a frequency response or a harmonic distortion, but we actually do the whole system as well. So this is actually a device right here. It's a Bluetooth gateway. So this is actually paired to that wirelessly. I should have probably said that earlier, but so yeah, in a sense, there's audio going through the mouth, and then there's wireless connection here. And it's now it's basically made a phone call.
You have questions for the other speakers?
Yeah, you guys might want to put toys, I'm sure.
Well, if you guys want to try the headphones, I can hook it up and we can have a quick listen. If we want to hear it on the speakers, we can do that too. But yeah, I brought the headphones to be listened to. So
What's the story on these speakers?
Yeah. What's that?
Well, on these ones here, we started in 2006 with a group of guitar players that wanted to start an audio club. And I was really busy with developing a wireless course. And I told them I had no time. They said, just got to sign the papers. I signed all the papers, and we got some funding, and they designed, we call it Revolution Audio. We had 4 speakers, and in a dorm, if you're sitting one way, you know, you have right and left and front and back. But if you turn, you'd like to have, you know, the left, you know, here now and the right there. We would rotate the speakers with a panel, touch panel, so that you could sit in different positions. They built 4 100-watt amplifiers, and then we built the speakers, you know, the cabinets and things ourselves, and designed those. And that was our first project that we did as a group. And then over the years, we've had kind of ups and downs on group projects. Sometimes a lot of interest, sometimes not a lot of interest. People with a lot of experience, like no experience. So we started evolving into kind of what we are today, which is anyone can join the group. We have no dues, no grading or whatever. And just what do you want to make? And then we try to find people that have more experience that help those that don't. And kind of do small projects, we do kit projects, just to get people in, just building stuff as soon as possible. I had one question. I read something that you had sent, but tell us about how you got started in electronics. It sounded pretty interesting from what I read, the little blurbs that you wrote us.
In 1958, I got a Heathkit FM tuner and a Heathkit 20-watt integrated amplifier, put them together.
Okay.
And the tuner didn't work at all, and I found finally a cold solder joint just when I was ready to give up the tuner. And the amplifier worked for 10 minutes and then made a loud bang. And I found out that I had routed the high voltage wire too close to a ground pin on a terminal strip, and it just broke down the insulation with pow. And once I replaced that and moved it away, then everything was fine. I almost wish I still had that stuff.
How old were you when you did that?
13. And then the first scratch building was when I was maybe 20. No, actually before that, I built some power supplies. We had a highly, I can say it now because the statute of limitations is running. But I was at a prep school in California, and we had a highly illegal 4-watt AM radio station. It's probably more than 4 watts. It was Knittel phone oscillator. Does anyone remember hearing of that? With 3 tubes, and we ran it from a 450-volt military surplus power supply and put in 5763 modulator and oscillator, and we ran a 200-foot long wire antenna across the valley. And some parents one day decided to help us figure out what our coverage was, and we were in Claremont, California, near Pomona. They could get us beautifully clear to Riverside at 8:40 a.m. And so no one ever came down on us. But I built another bigger power supply, but we never used it for anything. Yes?
As someone not totally familiar with the California cities, do you know, can you give us an approximation of how many miles?
About 35, we were about 35 miles due east of Los Angeles. And Riverside was another 35 miles, approximately, further east. And so we had a coverage of a radius of about 30 miles anyway, on 8:40 a.m., which was somewhat clear at that time. And it was fairly well known that we were illegal, but nobody ever did anything. As a matter of fact, we were befriended by radio stations, and I found out more recently that one of them was famous. We were befriended by KNX, the CBS outlet, and the year after I graduated, the KWeb staff was invited to go in the nighttime cruise cars called Megalopolis at Night with CBS Radio Los Angeles, KNX, and help do all the remotes and stuff. And then the other thing was, KWeb, Web School of California, was adopted by XERB in Mexico. And XERB is one of those border blaster, quote unquote, high power stations with studios in Los Angeles, and the chief engineer was named Paulo Jaquez. And it turns out at that time, that was the Wolfman Jack radio station. And they gave us some equipment, and they encouraged us and all that.
Awesome. Did you get a degree in electrical engineering? Or?
No, physics.
Physics, okay.
So at Arizona State, the engineering students and the physics students were kind of slightly at friendly swords points with one another. So if that's still the case, please spare me. Because I've sort of been in an engineering career despite my physics background all the rest of my life.
So I got this queued up. Hopefully it comes out here.
This is a 1982 recording transferred in 1988 with a PCM F1. Recorded on that.
We're just you walking around, right? With the microphone.
Wait till we get close to the end.
Yeah, there's a hat. So this is right now from the laptop to the DAC amp, and then
Actually, it's just laptop to this amp.
Okay.
Yeah.
the tape.
Thanks.
So Wade mentioned many Wulitzers and theater organs. Well, he's quite the avid player himself. So he spent some time playing. So this is
Ready
Wade.
to play it. That's one of the more boring ones.
Yeah.
The Newberry Memorial Organ at Yale University. It's 197 ranks, 1928. It's considered one of the 2 finest symphonic organs in the world. 12,800 pipes, 9 chambers, 5 levels.
That's got to be huge.
How about shades of
And all of these were recorded on the
These were done with the hat, right?
Wade also has one of the
This is-
first heads.
I didn't
Yeah.
know I could play this piece. I just decided
One of the
to
our
go
older
for it.
models of the hat.
There are mistakes coming.
transfer it over to the headphones. If you guys just want to come up, grab them, play some stuff.
You want to talk about how those recordings were made? There was some
That was
questions about
recorded with an Aachen Head HMS-1, the first generation, three-field equalized, about halfway back in the hall. And it was recorded with a PCM F1 Sony digital audio processor that would make black and white images, recorded on a Beta videotape machine. And the processor was modified by Jeff Rowland, the Jeff Rowland Design Group, and had the first generation Apogee 944 filters, and the entire audio electronics replaced by Jeff Rowland himself and Michael Grace, who this is before Michael Grace founded his Grace Company, making mic preamps and stuff. So that I still have, and it is beautiful sounding even now. 16-bit A to B.
Did that one still have hair? Wait, these are all
Yeah, it
bald.
still has hair.
They still have.
Mine has real
had
felt. The later
yeah,
ones had flocking.
that felt hair.
And had the
Let's thank them for coming to speak to us.
Thank you very much.
Thank you all very much for having us and letting us share our enthusiasm. We know what you're doing, and we've been doing it, and you have a great lifetime ahead of you in all this area.